So let's start with Event Mesh. What is Event Mesh? So Event Mesh basically was introduced by SAP mainly in order to work with events which are now triggered with S/4HANA systems. Yeah, as a product roadmap, as a vision from SAP to move towards event-driven architecture. Yeah, and mainly this Event Mesh is not introduced by SAP. There is a company called as Solace. So if I just do in Event Mesh, the first thing which comes here is the Solace. So this is the company who has built this Event Mesh technology. SAP has partnered now with Solace and rebranded that from its own basket of products. So anywhere if you speak about Event Mesh and so on, please remember that Solace is the company who has introduced Event Mesh. Event is basically where some actions is being done. So any action which is done, it triggers an event. That is what an event is. So you talk about any applications here, be it S4, ERP, any non-SAP or backend application. Let's talk about Ariba, IBP, any of these. Yeah. Uh, so here, let's talk about S4 here. Let's talk about any legacy ECC application, any, let's say IBP, Ariba, whatever. So at the end, even you talk about IDoc in your ECC application, anything which is posted, which is changed so you have change pointers in your table, right? That change pointers in your table, you will say, if anything changes in this table, I have to create an IDoc and then I have to trigger this IDoc to those partner systems. What is that? That is nothing but an event in a way. It's working like an IDoc way. So for example, ECC triggers an IDoc in your PIPO and those system. You receive this IDoc, and then you can add multiple target system to deliver this IDoc. Like let's say Matmas IDoc. Matmas IDoc coming basically from an ECC system triggered to a sender system PO. Yeah, sender system which is PIPO. And then in PIPO, you receive this from your one of the ECC system as one sender, but you can deliver it to multiple targets. I hope you are doing this one to many case. So this is nothing but uh, an ad hoc way of triggering data to multiple target systems using an interface in between here. Now, with events, with Event Mesh, what is possible is with S/4HANA system, all these data objects can also be triggered via an event. So if let's say you have a supplier as a business partner, supplier, product, then let's say uh, uh, document posted, order creation, whatever, document posted, order creation, then customer created, whatever. Yeah, anything, any data object if you talk about. At the end, S4 is capable to trigger events for those data object. So let's say a product, and if a product is changed, an article is changed, yeah, in S4 system, it can trigger an event, and that event can have some information like, for example, uh, there will be an event ID for some extra information, and then there will be this product ID. And that product ID would be, let's say, 0000123456 7. Yeah, that's the product ID, for example. And then you get this event. Yeah, and you know that something has changed in S/4HANA system for this given product, which has triggered an event. So that's an event basically. And these events are now, many of those applications, SAP applications are now capable to trigger these events. If you talk about Ariba, IBP, any invoice created in Ariba system can trigger an event. Any contract which is created within Ariba with a vendor, let's say, can create an event. And this event, in this event, you can say, Ariba will say, take this contract ID or take this information and then take this event, which means you can then know that something has happened at this contract level, and then you can take this event, and basically with this event you can pull that information by calling an API and getting that data from that particular system. But at least you will be notified by the source system that something has changed. So that's an event. Does it answers your question, Valley?
Yes, thank you.
Yeah. Now let's take a example. Let's compare it with this IDoc. Now the event is coming out here. Let's say we receive this event in an interface here. We have an iFlow. Forget about event mesh. If we want to retrieve the product information, and let's say there are three target system. At the end, you need to send this information to three consumers, three target systems or four target systems, whatever. So you will take this event. At the end, this event will come to your interface. You will then take the ID from this. Yeah, maybe you make a call to your S4HANA API to query the product ID. Yeah, and then this S4HANA system gives you the details about that product. Once you get the details of that product, then at the end, you will have to deliver this information to four systems. Maybe in future, there are furthermore two systems coming in. Then each and every time you are making this interface change, and you have to add that many target systems here. At the end, this interface becomes heavy. Yeah, and also if this target system, you have a different mapping here, you have a different mapping here, you have a different mapping. So here there is a SOAP API, here there is a REST API, here there is some other API. So at the end, this interface becomes a bit, operational wise difficult to manage it. And every time uh, an event comes in, and this interface is then responsible to deliver those events in parallel to all these five systems. So that's where what we can make use of is event mesh. Yeah, that's how you were also doing with IDoc, right? In the IDoc with PIPO world, you also have creating an interface like one to many, where you are adding many target, many receiver systems. So now with event mesh, what you can do is basically you have an S4HANA system here, and let's say you have an event mesh here now. Okay, so and this S4HANA system triggers an event. So in S4, you have event adapters. Yeah, that's built in. And event mesh offers a direct connectivity to S4HANA. Yeah, so I will go in detail later more, but event mesh offers REST based APIs as well. S4 will trigger these events. It will come to an event mesh, and event mesh has the capability now to itself uh, deliver these events to different target applications. Yeah, by replicating this event 4 times, maybe 5 times, 6 times, as many times you want. So you don't need to do any development, anything. It's just the inbuilt capability of yeah, event mesh to basically add many subscribers, and at the end, this event will be delivered to many target systems. At the end, what you can do is you can have interfaces as well, dedicated interface to process this event only for that respective target system. Here you can have another interface to process this to that target system, or maybe you can just deliver this event as it is to a target system. Let's say an example. For example, here if you are using any news or any entertainment application in your mobile phone. Yeah. For example, if you are using, let's say, Facebook or Instagram, or let's say any news application. Yeah. And now in their news application, there are different sections. There are different topics, I would say. One of the topic is sports. Maybe another topic is let's say entertainment. Yeah. Where is it gone? Okay, let me do entertainment. Another topic is let's say politics. Yeah. And now all these are nothing but users here. Yeah. So this is an user A. Let's say this user is Varun. Another is Magali. Another is let's say Alok. Another is Samant. So you all are nothing but we all are users of this application. So we all have downloaded this application in our mobile phone and we are waiting for some news to come up here. Now, this company here, let's say a news company will will not push the message to each and every user. Let's say, okay, Magali wants to now know what happens in the sports. Let me push a message to her. Varun also wants to know what happens to in inside sports, whether India won or lost, whatever, or maybe what happened in football. Let's say, so let's send a message here. Let's send a message here. That's not how it happens. So there are basically dedicated topics. Yeah. So one topic is sports, one topic is entertainment, one topic is politics. Yeah. These are nothing but topics. We say it. Yeah. And then this news company, what it will do is it will send a message to a topic here. Let's say this topic is a sport. And now in my handy in my mobile phone, I go to this application and I say, yes, I want to receive notification for sports. I want to receive notifications for politics, for entertainment. Yeah. But at least 3 users here are interested in knowing what happens in sports. So as soon as the message is pushed to this topic, and then there are consumers, 3 consumers who have subscribed to this topic. So that's where a subscription happens. Yeah. Uh, there is a 3 subscription to this topic. As soon as the message is sent to this topic, this message will be automatically delivered to all the subscribers. Yeah. So that's how this pub sub model works. It's called as a publisher and a consumer. Yeah. So remember this term as well, pub sub, topic and subscription. Yeah. So these are some terminologies which are used in an event driven architecture in especially also in event mesh or things like that. So here this news agency is sending a message to a topic, and then inside for this topic there are 3 users who have subscribed to this topic. So at the end, between these systems, the message is just sent one, but such brokers, such event mesh brokers have the capability now to push this message to all of its subscribers. Similarly, if a message is pushed to an entertainment topic, at the end, it will be delivered to all the subscribers who have subscribed to this topic. And the last thing would be for politics. So that's how in general it works with event mesh, and that's why event mesh is now gaining its popularity as well. Why many wanted to use event mesh as a product, because you have such capabilities of working with events, especially with S4HANA system or any other non-ZAP or ZAP application systems who are capable to produce events. And it's not just necessarily only events. At the end, this is just a payload. It's a JSON payload. It's an XML payload. Yeah. At the you can say it's if there is an system, let's say maybe in your company you have a car, SAP car, or maybe maybe some other non-SAP system, and that non-SAP system sends a payload, actual payload with a data object. You can still ask that system to send that information to an event mesh. Yeah, to a queue in the event mesh. It does not matter to event mesh is that it should be an event containing some information of the object which is changed, or it can be an actual payload as well. At the end for event mesh is just a message. So you can utilize it based on your convenience, what you want to use it for. Let's say in my project, in my thing, I also use it for actual data objects, like actual data events where the events contains the data which is changed. And I also use it for just like an event notification. So this is nothing but a notification, an event which is sent as a notification. This is nothing but an actual event which contains data in it which is changed. It's not a notification, but it is an actual data which is then changed. And for both the purpose, you can use event mesh. Yeah. So the that's something a bit of context about event mesh. So here there are some features about event mesh. So you can publish business events. This is what this example here is. News company or S4HANA system. What it is doing is it is publishing events within the event mesh. It is publishing the event to this topic. Yeah. So that's how publish events, business events. Publish business events from SAP and on-SAP across hybrid landscape from digital code to event-driven architecture. What is happening here is a consumption on this side. So this is nothing but consuming an event. Yeah. Consume business event SAP blah blah anything like extension to integration suite. You can even consume events using your cloud integration IFlows. Yeah. Or any other system. Connect seamlessly. So there are many ways to consume this event from event mesh, even to push the event and even to consume the event. You can use a REST adapter, HTTP APIs of event mesh to push an event. You can use an HTTP API offered by event mesh to consume an event. You can even push an event using an message protocol adapter. In CPI, it is called as an AMQP adapter to push the event. You can as well as use an AMQP adapter to consume an event. So there are many ways to basically connect to event mesh. Yeah. So this is nothing but some overview. So event source, it's generating an event or maybe, yeah. And then there are many integration ways, communication wise, flexibility wise, you have different capabilities within event mesh where you can uh, retrieve this message, do some processing, and then push this event to third-party applications. Yeah. So let's say you take this event, you have an iFlow, then you are processing that event. Once you have processed that event, and at the end, you're extracting the required information out of that event and sending it to a third-party application. Communication is this what we talked about. So and news topic was and a news thing was published, and at the end published to a topic and it communicated to different users. So that's also possible from event mesh. Yeah. uh, 1 second please. So those are reliability is basically uptime. Since it's cloud based, so SAP says 99.9% availability. Uh, Messages can be retried, are not lost. They ensure that the delivery of the message happens. So these are something which is offered within event mesh. That's why it's said it's reliable. Yeah. So now let's jump into uh, the topic itself. Overview we have seen. This is nothing but the same sections which we read. Anyway, this is feature scope. It's nothing more here. Pricing we can see a bit later. So it's pay as you go model. This we can see a bit later in a way, but that's all I would say. So then can we jump to Event Mesh? I mean, I can give you some overviews there or show the application. And as of now, do you have any questions with respect to this introduction, which we did? Terms and all what I have mentioned here, like topic, subscription, queues, publishing the messages, consuming the messages. These are all things we will look into the application directly. We will try it out with interfaces, with cloud integration. We will also see some capabilities from Event Mesh. But overall, this was just an introduction. So here are some concepts which are already part of, which are given here, which I think let's go looking at this at least once. So here what it says, the queues. So in Event Mesh, basically what you can do is you can create a queue. Yeah. And you can ask your consume publisher to push the message directly to a queue. At the end, you may have a consuming application which is consuming a message from a queue. So for example, our JMS queue. So in the JMS queue, there will be one publisher or a sender who is sending a message to a JMS queue, like a receiver who sends a message to a JMS queue, and then a sender who is then consuming a message from the JMS queue. Yeah, so that's a queue. So what it means is, let's say here, these users are nothing but, let's assume that these users are nothing but queues. Yeah, so there will be a queue for Varun, there will be a queue for Magali. Yeah, for example, here Magali, there will be a queue for Alok and so on, different users here. Let's say a message push to a topic ends up into dedicated queues of these users. And for example, your phone is switched off. For example, how it happens in WhatsApp, how it happens. So if your batteries is down, your WhatsApp is switched off or your phone is switched off. As soon as you turned on your switched off, as soon as you turned your phone on, all the messages are delivered to you. All the notifications are delivered to you. So how that happens is because the messages were all in the queue here. As soon as the consumer got active, those messages were all pushed to that consumer. Yeah. So at the end, every information is stored in a queue, be it pushed to a topic. So the thing is, yeah. So first there is only a queue. So remember, there are concept of queue. This is a queue, and then there is a concept of a topic. Yeah, a queue, and then there is a concept of a topic here. So one topic can have, let's say, copy and paste it here. One topic, a queue can subscribe to a topic here. And basically, there is one more topic here. And this queue here can also subscribe to this topic. Yeah. So at the end, it's many to one relationship. So one queue can subscribe to multiple topics. Yeah. Let's say this topic and this queue belongs to an individual consumer. Let's say this belongs to Macaulay. This belongs to Varun, for example, here. And this belongs to, let's say, a group, for example, Alok here. Yeah. So we three are the consumers. We all three have a phone, and in our phone there is this application of a news channel, news application. This topic belongs, let's say, a sports, and this topic belongs to, let's say, politics, because we are interested in this. For, let's say, politics. In politics, we all three are interested, but in sports, only, let's say, Magali is interested, for example. Now this news agency or a company will trigger the message to both the topics. Let's say if there is a change, something happened in spots, it triggers a message in the spots. If something happens in politics, then a message is triggered to the politics. Now, at the end, as soon as the message is triggered to a topic, this message is visible in the queue of Magali, but this message will not be visible in the queue of Varun or Alok because we are not subscribing to this topic. And if a message is pushed to a politic topic, this message will end up into the queue of Magali, into a queue of Varun, and also into a queue of Alok. Yeah. And let's say if now there are two messages in the Magali's queue, which includes a message from sports event and also from the politic event. But Magali's phone is switched off. So the message remains in this queue till the time Magali is active again, has switched on the phone, is as well in the network, and then all the messages will be sent as a notification to her cell phone. And then this queue will be empty. So that's how this works in a way. But then there is also a way, let's say a system here can also send a message directly to a queue here. Yeah, does not need that this needs to be sent to a topic. As soon as the message are published directly to a queue, which means only Magali wants to know that message. No one else wants to have it. So that's how a publisher can publish a message to a queue directly, as well as a publisher can publish a message to a topic as well. But if a publisher publishes it to directly to a queue, that means and from a queue, there can be only, let's say, one subscriber. Let's talk about JMS. From JMS, only one person can pick, only one interface can pick, can subscribe to that queue, right? JMS queue. That's the same thing with Event Mesh as well. So it Event Mesh, then only Magali gets this message and no one else gets it. So that's what the concept says here. If an application is pushing a message to a queue, then only a particular application which is subscribed to this queue will get that message. Yeah, that's a pushing a message to a queue and the queue subscription in a way. Now let's talk about this one. An application, a news application can push a message to two different topics. Here it's a sports and here it's politics. And at the end, this queue is subscribed to both the topics here. Yeah, so this is what happens in our example also. We have two topics here, and this queue of Magali is subscribed to both the topics. And at the end, the phone of Magali here is getting all the notifications from here. Yeah, so that is nothing but here is the phone of the Magali, here is the queue for Magali, and here is the news company who is then publishing to this topic. So that's how a queue subscription works with the topic. Yeah, so this is how the event is. So event source is pushing a message to a topic. For a topic, there is a queue which is subscribed to a topic, and then that message is getting received to in that particular queue. Yeah, so at the end, let's talk about this is something on the consumption side. So a publisher can publish a message to a queue, and then there are several ways where a message can be read from that queue. And one of the ways is called as a webhook subscription. You might have heard this term webhook, maybe somewhere read in some blogs or somewhere. We will see this how this webhook works. So webhooks are called as are in a way used to subscribe to a particular events. So and these are usually based out of HTTP protocol. So in CPI, you use your HTTP adapter, you create a simple HTTP endpoint, and you take that endpoint and you create a webhook subscription in Event Mesh. As soon as the message comes here, it will be pushed to our IFlow. using this webhook. So that's what the webhook subscription is in a way. So we will see this with live example, but these are some concepts which I wanted to show you here at the end. What are the possibilities which we can take from event mesh? Did you understood the concept of queue and topic and the subscription of a queue over topic?
Yes.
So now let's see the application itself. This is a dedicated application. It's not clubbed with integration suite or something like how we saw with cloud integration and API management. So it's the own application, its own product. So the first concept here is so you cannot directly go and create a queue here or a topic or whatsoever. In event mesh, everything starts with a message client. So you need to have a message client, and then for each message client, inside each message client, you can then go to the message client, and then you can basically create the queues and things like that here. Yeah, so that's where you can create the views, webhooks, and so on, the terms which we talked about just now. So creation of a message client is important. Yeah, and the message client, you can create it using the instance in instance and subscription. You have this section instances, and that's where you can go ahead and create an uh, uh, message client. Yeah, uh, but we will use the one which is already created. So this event mesh ITS def, which is already created here. For creating this, there is a standard payload or a JSON file which you can put it and you can create it. There are some information which you can give, what is the size you want, some rules and things like that. And based on that, this message client will be created. So at the end, you can have multiple messages client to be created here. For example, what we do is we create two message clients. For example, one is a provider message client and the second is a consumer message client. So a provider message client is, in a way, if a sender system is a source system is sending an event, and that event the only consumer for that event is our cloud integration, our middleware IFlow. So the IFlow takes that event and processes it. So no other than us are the consumer, or we are the only ones who are, let's say the integration IFlow is the only one who's consuming that event. Then we create those queues in a provider message client so that a sender system sending any events, a source system sending any events for which our IFlow, our integration IFlow is consuming it, then those goes in here. So those queues are created here, and let's say those events will be received here, and our IFlow will process those events. And if we from our interface needs to send out events to different consuming applications, to many subscribers, then we create a queue here called as uh, consuming message client, like providers and consumers. So for example, you have a real-time scenario where I'm not sure if you may have any non-SAP application or an e-commerce application. Let's say a consumer is shopping something and an order is created. And now you want to send this order to multiple target system. Yeah, everyone wants an order which is created by a consumer, by a customer. And it's needed by your S4 system, your backend system, maybe some other, maybe an Ariba system, or maybe an IBP, or a logistic provider who also needs information about this order. So what we do is we create that particular topic and a queue in the consumer message client, and we ask that source application to trigger the orders to that topic or to that queue in that, and then we will have all the queues for by which it will be distributed to all those target applications created under that message client. So those are nothing but will come under the consumers section. So that's what we do in a way. So we have two message client, one for provider, and for providers is just that we from integration side are consuming that event and no one else. But for the consumer side, if a message is sent from a source system and it needs to be delivered to multiple target system, then we create all the queues in that message client. Like how you saw an example now of, I gave you about this news channel. So a queue for Makali, queue for Varun, queue for Alok. So those are nothing but you can name it as 3 different applications, and those 3 queues will be created on the consumer side. Yeah. So, and so first of all, whenever you in the default plan, you always have allocated resources. So for this event mesh, the allocated resources, let's say it's 200 units. Yeah, which is there allocated. And then you can create message clients. So for each and every message clients, there will be some amount of units which will be then consumed. Let's say this message client which you have created based on 10 resource units. It's 10 is the default one. So whoever has created this message client here have used directly the payload, which is sample payload, which is there, and have created this. So that's why it got created basically with default resource units as 10. I will let you know how this comes into use. OK, which means if you have created with 10, then in the default plan, you can create 20 message clients. Yeah, in your one event mesh instance. Or you can scale it up to maximum 50. This can go up till 50. So you can create one message client which can have maximum of 50 units and the minimum of 10 resource units. So if you do it with 50, then you can create 4 of them, 4 message clients, and so on. Now, with respect to this unit, as I told you, there are different resource like things which you can do. You can create a queue. From that queue, you can have a subscription from the queue, active connections to that queue. Yeah, consumers, producers, and webhook. We will see these concepts in detail. But for example, if you create a queue, yeah. So you mean if you have created a message client with 10 resource units, that means in this message client, you can only create in total of 30 queues. That's a limit which you have to deal with when you create a message client with 10 resource units. If let's say if you create it with 50, then you can multiply this by 5. So you can create 150 queues. Yeah. So that's how things change, basically. So there is a limit now for this message client to only create 30 queues. Let's say now if you create one queue in here, and then you try to consume a message from that queue. So you have to consume a message. There are different ways to consume a message. You can subscribe to that queue. Yeah. Let's say this is a queue subscription, which we saw about topic. Yeah. Like you can, for one topic, you can subscribe 10 queues, 5 queues. So one topic, you can only subscribe 150 queues. So that's what the queue subscription is. So if you created one topic, let's say there is one topic for sports, you can only deliver this message to 150 users at the end. That comes with the limit then, right? So,
sorry, I don't understand, because if there is only 30 queue, how can we deliver to 150?
No, so at the end, this topic, so if you see, the thing is, if you have two message clients here and here,
Yeah.
and in this you also have queues. But if you created a, if you have a topic in this message client, you can as well have you can as well subscribe to this topic from another message clients. Getting my point? So so for example, you have a message client, let's say A, then you have a message client B, then you have a message client C. Okay. In your A, you have 30 queues. In your B, you also have 30 queues. In your C, you also have 30 queues. Now, let's say you create a topic here. So first of all, topics are not created in any message clients. Yeah, I will show you that also there. But let's say if you create a topic here, but you can also subscribe to this topic from your message client B and from your message client C, which means you have a queue subscription of 90 queues, 30 from this, 30 from this, 30 from this.
Okay. Yeah.
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 So that's how you can also do. But for this, you can only have, let's say, a queue subscription up to 150, for example. Let's say if you have created a queue and now you want a webhook subscription to that queue. So a message goes into that queue, should be triggered out using a webhook. Let's say a message goes into a queue and you want to receive that message in your IFlow and you created a webhook here. So which means you can only create 30 webhooks. Sorry, 10 webhooks. You cannot create more than 10 webhooks in this resource unit with created with 10. Yeah. So here you see in your this thing. Sorry, not in here. So when you go here, so you have a section for queues. You can only create 30 queues. And then there are webhooks. You can only create 10 webhooks here, not more than that. Yeah. And then there comes active connections. So for example, you have now, let's say a JMS queue. And if you create a JMS adapter, I have shown you right before, whenever you create a JMS adapter, it creates a socket and that connection remains active 24/7. Yeah. As soon as the message goes into a queue, it's fetched by that JMS adapter. The same thing you can do it via an AMQP adapter. So AMQP adapter in our CPI, you can create an AMQP adapter and connect it with this queue. And that connection will remain active forever, 24/7. And that's how you can have 10 connections created. So which means you can only connect 10 AMQP adapters, let's say 10 interfaces with this message client. Yeah. And let's talk about here. Consumers. So webhook, we are creating one webhook. At the end, there is a consumer who is consuming this message, right? So here it says each webhook takes 3 consumers, which means if you are creating one webhook, it will consume 3 units out of this limit of 30. That's how for 10 webhooks, you have the limit of 30. Yeah. So that's what you have to consider whenever you are creating this message client. And then you can see this in the usage section, how your queues are getting consumed. Right now, we do not have any queues. And this usage section will be on your entire allocation, which is 200. Yeah. So that's where it gives you like you have an allocation of 200, right? So for 10, if it is 30, then for 200, it should be 600. Correct. So that's why it shows here that you can have a total of 600 queues created. Active connections. Somewhere there is an active connection. Someone has, I don't know, maybe I've connected this. So it shows 1 out of 200. I don't know, maybe could be or let's say, but producers, consumers and it's pooled. Yeah. So here you will see active connections, consuming connections, and so on. So if any limit is reached, let's say if there are more webhooks or more consumers who are consuming messages, some consumers may get an error saying that there are no connections left to consume a message. If you get these kind of error message, then you always need to come and see whether your resource usage is getting uh, occupied or not. Could be that your entire resources are getting occupied and you cannot basically consume more. Yeah, things like that. So that is what you can do. Yeah, sorry. So this is what you have to check. So I would recommend to 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 have this message clients created with an allocation units of 50, because usually you don't need like 20 message clients to be created. Maybe you create 2 or 3 or 1 or 2 message clients, but at least created with the highest number of resource units, which are 50. Otherwise, if you create 10, then you may end up facing those connection issues or resource consumption errors, or no more connections left, and those kind of errors. Okay. So that's one thing, and it's very easy to change. So whenever you are creating this message client here, just there is a attribute in the payload which you have to give, which is this number. So you can give 10, 15, 20, 30, 40, 50, and then you can give there 50, and then you will have another message client created with a use resource allocation of 50. Okay, understood?
So how do you decide how many like message clients we are going to create? Like, is it one message client per source system?
No, 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 no. I mean,
Mm.
you can, it's up to your strategy. Usually, if your source system is generating a lot of events or a lot of messages, then you can have one message client for that source system. But in general, as I said, we only like in our in my area, I only create 2 message clients. One is for producer and one is for consumers. And for producers, there can be many source applications creating events or messages. And at the end, all this comes in a queue here on this side. So the producing applications are creating messages which are going in the queue, and then the interface is picking that message and maybe processing it. So
Okay. Let me put it like this, Varun. Let us say I have two source systems. One is S/4HANA, and the other one, let it be SuccessFactors or Ariba, or
mhm,
something which supports event-driven architecture. So
yes,
both the systems are capable of generating events.
correct.
So in such a case, can I create only one message client that can
So
bring events from both the systems?
yes, why not? Yeah, you can. So at the end, what is your scenario? Yeah, if the S/4HANA generates an event, see, there are 2 things. How can I open Paint here? Uh, Let me see if I can hijack Macaulay's system and open something there. No, or here.
Yeah. Do you want me to open it for you?
Uh,
Okay.
mhm. Okay. So see, there are 2 scenarios which how you can do it. Oh, come
Okay. Let me grab it for you. It's on my second screen.
on. Okay, yeah, you can
Just give
pull
me a
it here.
minute. I just need to find my mouth. Okay. Here we are. Okay.
Thank you. Okay, so then so there can be different scenarios. So you mentioned your S4 system, and S4 system then generating an event which comes in the event mesh. Yeah. Now
Yes.
you got this event in a queue. Okay. Let's say this is an event mesh, and in the event mesh you got the message in a queue here. You created a queue called as queue for I don't know. What do you want? Article queue, like an article change, maybe. Yeah.
Okay.
Uh, and then how you want? You want your integration flow to read this event, correct? Right?
Yes.
So then your iFlow consumes this event here. Yeah, here is your CPI iFlow. Yeah, CPI iFlow here. Now, once this event is consumed, then what do you want? Do you want to uh, deliver this event to different target application, or you want to keep the information in here itself? What do you want to do? So, uh, for example, if you want, if there is a if there is an event came in, and now you want you retrieve some information from this event, and now you have to deliver it to multiple applications, correct? Usually that is the case, right?
Okay.
So
Yeah.
you may have a target application A, you may have a target application B, you may have a target application C, which wants this information, correct?
Yeah.
So what you can do is, first you can take this message here from the CPI iFlow, maybe do whatever you want with this message. Yeah, at the end here. Uh, so and let me think. Mm, yeah. So let me undo this. So in that case, you will have one message client here, and this, if you, for example, if you have to deliver this message to multiple consumers, then you should create only one message client. Yeah, calling it as a consuming message client, or whatever you let's call it an S4 message client. So a message which is coming to this topic here from S4 side, and at the end will go into 3 different queues here within event mesh. Yeah, so you will create all these 3 queues in that event mesh message client. Yeah, so this message is then replicated to three different queues, correct, which is within this event mesh.
Yes.
Okay. And here one and here one, for example. And then you have 3 different iFlows, 1, 2, and 3 iFlow, who are then consuming this message as a webhook or an AMQP adapter from each of this queue. So this is an iFlow 1, this is an iFlow 2, and this is an iFlow 3. And in this iFlow, you can have a mapping and then sending that message to target A. You can send this message from here to target B, and you can send this message to target C from here. Yeah, so you can do it like this, one way. Okay. And this message client, let's say you can name this as article queue S4. In the same message client, you can also have, let's say from Ariba, you are receiving, I don't know what information, like contract information. Yeah,
Yeah.
or what? So you
Yeah.
can have,
Mapping contract information.
like you can say Ariba contract queue. Yeah, and this queue as well, you can create it in the same message client. Yeah, and then here will be same Ariba application sending this. 1 minute, let me cut this. And I will create another topic here in the same message client. Let's say here there is a topic in the same message client, and that topic is with the name like this. Ariba contract queue. Yeah, and then you can also do the same action here. This one topic will then be subscribed to multiple queues, and then you can deliver or you can create webhooks from those queues and deliver to that application using IFlows. So that is one way you can use your message clients for different source system as well. One message client for different source system. But if you have, let's say, only 2 or 3 big consumers or big providers for which you want to use event mesh, then you can as well as create message clients for those consumers dedicated. In a way, for operations, it might also be easier for you, because then you know that if there is a ticket which is raised from S4, then you know that you have to check it in this message client. If there is a ticket which is raised for Ariba, then you have to come in this message client, and all the queues for the Ariba will be in here. Yeah.
Okay. Yeah. So one thing, Varun, when we're dealing with topics, they are decided by the source systems itself, or we will create the topics. Like, how
So
does it work?
we create the topics in event mesh, and then
Okay.
we give, and then there is an endpoint which is generated. I will show you how. And you have to give that endpoint to this system and say, take this endpoint and trigger the message to that endpoint. And then once they trigger that message comes to this topic. And automatically within this topic, it is replicated to all the subscribers, to all the queues. Okay.
Okay. Okay.
I will show you this here.
Yeah.
So, but you understood this use case, right? So you can create a
Yes.
message client from, let's say, S4 message client. You can create a message client for Ariba message client. Let's say for S4, you have 6 or 7 data objects, right? So you can create a message client with a resource allocation of 50. For Ariba, let's say you only have 1 or 2 interfaces, not more than that. Then you can maybe create with a resource allocation of 30 or 20, for example. Yeah.
So can we decide the resource allocation based on the message flow that we can expect? Message flow.
Message flow does not matter, because message flow will matter at the end with your subscription, like pay as you go, depending on the number of messages which you have published, and the number of messages which you have provided, and the number of messages which got consumed. Yeah. So at the end, this, oh shit, sorry. So here, based on number of number of messages you have provided and you have consumed, that depends. Message client depends. I would say you should decide based on your number of interfaces. Like, for example, if you, like here, I gave you an example that this needs 3 queues, right? Then maybe you also have one more data object, not article, but let's say prices for article. And that prices needs as an event also came in, and then it also needs to be delivered to 3 or 4 systems. So then those queues will scale up to 6. Then there is also one more, let's say, a supplier or business partner change. So I would say depending on the number of interfaces and the consumers which you have to send that message to, that's how you should decide the size of that message client. But it's also that today you created an S4 message client with a resource allocation of 50, and you saw that you have already come to a limit of that. You can again create a message client with S4. You can name it as S4 message client instance 2, for example, and create another message client with S4, and then can add the remaining interfaces in that message client.
Okay, instead of the content dynamically increase the resource units for that particular message client without any impact.
No. This is not possible. So once the message client, you can increase the limit of your entire event mesh. You can change this, but once the message client is created, this cannot scale up on its own.
Even if we like update the service descriptor.
No, I think I have not done that. Maybe once this is created, I don't think so there is an option to update it. but maybe you can try, or I will also have a look if that is possible. But as far as I know, once it is created, it is created. You
Okay.
cannot change it.
Okay. I'll just summarize my understanding here. Just correct me if I'm wrong. So a message client can be like kind of connected to many topics from many different source systems. And in the same way, uh,
Can you
it
please?
depends upon like sorry, you want me to repeat it?
Yes,
Okay. So
please.
what I'm trying to say is a message client, okay, can be connected to multiple source systems, like with
Yes,
event-driven architecture.
correct.
And at the same time, that like a number of queues that are connected to a particular topic determines the like duplication of that particular messages, right?
Yes, yes,
Okay.
correct. So you can have dedicated queues, and you can ask this source system to also push a message directly to a queue. Yeah. Or
Okay.
you can ask this source system to push a message to a topic. So both is possible.
So what
Yeah.
would be the best approach in real time? Like how do we?
It depends on your, let's say if you have let's say Ariba, if you only need to deliver contract information to S4 system, right? For example, because mainly these documents and this information goes into only one target system, let's say, which is S4 here, right? So you can tell Ariba to push this information directly to a queue, and you can name this as Ariba contract queue. Let's say you can name this as, for example, data object, which is contract invoice or merchandise contract uh, from Ariba to S4. Yeah. So like you can name this queue directly like this. Oh, what happens to 4? Okay, maybe I don't know. I'm not here. So my keypad is not okay. Something like this. And then when Ariba sends a message directly to this, so it comes directly to a queue. So at the end, there is only one queue. And from this one queue, you have a dedicated interface in CPI, which is consuming a message from that queue and doing the respective mapping and whatever, and sending that message to S4.
So we are bypassing the message client concept here and we are directly pushing it to
No,
a
no,
queue.
no. At the end,
So
everything is in the message client here.
now in the same message client, right? Okay.
Yeah, in the same message client. So
Okay.
you're
Yeah.
creating this queue in the same message client, and you are naming the queue as contract Ariba to S4, so that you know that this queue receives contract information from Ariba and it goes to S4. Yeah. And at the end,
Okay.
this queue will have no subscription to any topics. It will just be an dedicated queue. And Ariba can push this information to this queue directly. If you
Oh,
need
okay.
this contract information, let's say any new system comes in, now is S4, but let's say Salesforce comes in and it says we also want contract information because we want our consumers or customers to see this contract data or documents. Then at that case, what you will do is you can now tell, because at the end, if you will again create a queue and
Now
call that,
topic is required, right?
yes, now topic is required. You're correct. Because now if you will create another queue saying that contract Ariba to Salesforce, now this queue will not get a message. At the end, Ariba has to push this message 2 times. One is to this queue and another one is to this queue. Yeah.
So
And
a
then
topic is capable of duplicating the messages and for like sending it to various queues, right?
exactly, that's why it is called as a topic. Yeah. And then, so this is one interface which sends the information to Salesforce, contract information, and this is one which sends information to S4, let's say. Yeah. So uh, now if you ask Ariba to send message to a queue directly, then they have to push the message 2 times here. So what
Mm.
then you can do is, if you have those data objects which you have to deliver to multiple target systems or multiple consumers, then the best scenario is always to create a topic here. So you can ask Ariba then to push a message to a topic, and you can name this topic as for example, you can name this topic as just saying contract, generic name. Let's say contract topic or contracts from Ariba. That's it. Yeah. So contracts from Ariba are all coming here, and at the end, this line, we don't need this line then anymore. This one is, it's very hard to basically work when I am on another screen. So at the end, this line goes off. So now Ariba is just pushing a message once to this topic, and the other connections is the subscription, which is then used. So this is here, and from here there is one subscription which goes to a queue of S4, and there is one subscription which which then goes to a queue of Salesforce here. So that's how you can use this topic and subscription model.
So even if I wanted to feed it a single queue at that time, for the time being, it's better to use a topic and then feed it to the queue so that in future I can add more
Can
queues
scale
to
up.
consume from the topic, right?
Correct. So that's always good to always have topics rather than providing queue names directly, because you never know if you have to scale up, if you have to add more queues, then you can do it on with a particular topic. But if you initially created a queue and then later on want to change to a topic, then you have to change that endpoint. So the consumer needs to do a change on their side.
Okay.
So if you from beginning, if you always give a topic, then you can add 10 more consumers here. You don't need Ariba to change anything. Ariba will still send this information here, and at the end it will be replicated all over.
So yeah, one more question, and it might be very lame at this point, but I still wanted to ask. So the topic gives me the capability of duplicating the messages through event mesh, but I can still achieve a similar thing through an iFlow, right? Using multicast.
No, how can you do that? I mean, can you explain me in a
Let
how?
us let us say I'm using a parallel multicast
But
or sequential multicast, right? Where I can still duplicate a one message to multiple receivers.
yes, but if you have one iFlow here, you have to do a development, right? You have to add a route and then add a queue there,
Okay.
right?
Okay. Okay. Yeah.
So you have to touch the interface, edit the interface. For that parallel multicast, you have to create a route and then add a target and then send that message to a queue, basically. But in event mesh, you don't need to do any development. It's just creating a queue, which is in 30 seconds you can create a queue, and it takes 5 seconds to just add that queue to this topic. So at the end, you can do this directly in production, or maybe indirectly anyway. You don't need to transport nothing, anything. It's just a configuration.
Okay.
And
Okay.
what you have
Okay.
achieved is you have replicated that message as many times you want without having a dependency of doing it via interface.
Okay. Yeah, got it one. So instead, I need not touch existing iFlow or the interface setup. I can just duplicate it and put it in a different queue and start my development only specific to that consumer or receiver or
Yes,
whatever.
correct. So let's say if you now have a queue for a message in the S4 in the Salesforce queue, or if you have a message in an S4 queue, then you start the development directly for an outbound interface to convert this message like how S4 wants, or to convert that message how Salesforce wants, and then only do a development here, but nothing changes on your inbound side. Your inbound is quite flexible. At least nothing changes on the Ariba side. Ariba don't even know to how many applications you're sending this.
Yeah,
Correct?
got it one. Yeah.
Yeah. So that's the flexibility what Event Mesh offers in a way. Thank you, Saman, for asking all these questions. They were all quite good and relevant, and basically since the session became interactive, So I hope the others have also got the required knowledge about why we should use Event Mesh or what capabilities Event Mesh offers as such.
Yeah, thanks, Varun.
Yeah. So we will all see these concepts in our subsequent sessions now, like how to create a queue, how to create a topic, how to subscribe a queue to a topic, then how to publish a message to a topic, how to publish a message to a queue directly, how to publish a message to a topic directly, how to consume a message from a queue. We cannot consume a message from a topic. Yeah, we can always consume a message from a queue. Please remember that. Yeah. So it's not like and a message goes to a topic, at the end it goes to a queue. So every topic needs to have at least one queue subscription. That is important. And only a consumer can subscribe only to a queue. It cannot subscribe to a topic directly. Yeah. So basically these are some things which we have to remember. But apart from that, if you have understood this concept, I would say doing it is relatively more easy, I would say. Yeah, consuming it via Webhook is very simple, very easy. Even with AMQP, it's also easy. Yeah, we will see these concepts. There are channel configuration in the adapter which you have to do, but that's nothing very difficult or something which cannot be managed. So let's focus on these parts in our subsequent session. Then wish you all a good evening and talk to you all tomorrow.